So we have already discussed two definitions. The first one is about point. A point is that which has no part. I was explaining point has no part. Fill in the blanks question will be there. True false question will be there. What is the meaning of that? The meaning means point has no part. That means point doesn't have any length. Point doesn't have any breadth. Point doesn't have any dimension. Okay, no measurement is there for a point. Okay, length is a breadthless. Okay, we were talking about a straight line, and a straight line is a breadthless length. That means when we are talking about a straight line, that is just a length we are having. Sometimes we end up drawing a broader line and we call it a straight line. That is not a line. We cannot make it broader. With the help of very sharp pencil, we must draw it like that. So that is, yes, breathless. There is no width. Okay. There is no width for a straight line. Let's continue after that. The third definition. Yes, you don't have to memorize fully these definition, but you should know, because fill in the blanks will be there and more than half of the statement will be written over there. A point is that which has dash. A point is that which has dash. So you have to fill over there. No part. Okay, no part. Next one. The ends of a line are points. The ends of a line are points. It is also one of the definition. Okay, so end of a line, when we are drawing, you see, obviously the end is a point, and that point we also name it point A, point B. Yes or no? Whenever we are talking about any straight line, we know the end, the extreme end of both the side, it's just a point. It's just a point. Okay, so end of a line are what? It's a point. Now let me tell you one thing. Let me tell you one thing, that when we are talking about this line, it is made up of point. How many points? So many points are just attached together and making a line. Okay, so this line is made. How we are having this line? It is just completely made with the points only. You can connect it with, all are just combined together and giving us a line of very like minute point, like that. We are having so many points, and that is giving us a line. So whenever you see a line, you need to understand it is just the combination of so many points. So many points are attached together. So many points are attached together to make this line. Okay, one example in real life you can take that if we are talking about the thread is made with, if I am talking about the cotton thread. Okay, cotton thread, the thread which we buy from the market, the reel of the thread. Okay, which we buy from the market. This cotton thread is made with the, like, this cotton thread is made with the cotton seeds. We get the seeds from the tree. Okay, and in these seeds go in the factory, and in the factory the machineries and everything just convert this seeds just get converted into the thread. So are you able to connect that we are having so many seed, and that is giving us a line? Thread is what? Thread is just a line. Not only line, curves also we are getting. Okay, if I am drawing any curve like this, it is also just the combination of point. So many points are just attached together, combined together, packed together, is giving us a curve, is giving us a straight line. Are you getting it? Are you understanding? So what was the definition? The definition was the end of a line are what? The end of a line are point. Okay, we must know that line is completely made with the points only. So end is a point. Okay, you will see in future that more definitions are there which will indicate that, like this. The next definition is the straight line is a line which lies evenly with the points on itself. The straight line is a line which lies evenly with the points on itself. Can you see whatever I was explaining just now? That line, how line is made? Okay, how we are having a line? It is just completely made up with the points, so many points, and that's what is written in the question. The straight line is a line which lies evenly with the point. Okay, there are so many points which is lying evenly on this line. Getting it? Yes, today no one has turned on their camera. Please turn on your camera first. Yes, first turn on your camera. Samya. Yes. Everyone. Anam. Arhan. Bharti has already turned on. Furkan has already turned on. Hanan. Heather. Okay, Shad has already turned on. Furkan. Samya. I can't see any other student. Please turn on your camera.
No, 1 minute.
Yeah, sure. I'm giving you 2 minutes. On the camera, we are continuing. Yes, I can see. Okay. Yes, like this only. Okay. Yes, still I can't see Samya, Anam, and Arhan.
Ma'am, actually my camera is not working.
Okay, Arhan, you are saying. Okay, Arhan. Anam. Yes, Anam. Okay, let's continue. So here what the definition says? The definition says a straight line is such a line. A straight line is such a line. Can you see my screen?
Yes, ma'am.
Yeah, let's continue. So it says that a straight line is a line. That means a straight line is such a line which lies evenly. That means which is having evenly points on itself. Which is having evenly points on itself. A straight line is such a line which is having points, like the points are all over it. Okay, arranged evenly. which I was talking about. Okay, and the example also I have given you, it's not just about the straight line, it's about the curve also. Okay, the curve is also completely made up of points only. So be it a straight line, be it a curve, it is completely made up of points. Okay, now the next definition. First, let me know whether this definition is clear to you or not.
Yes.
Clear.
Yes.
Let's continue. Now the next definition is the surface. Just a second. Yeah, the next definition is the surface. Surface is that which has length and breadth only. The surface is that which has length and breadth only. Obviously, when we are talking about a surface, it has length and breadth only. Let me show you one book. Can you see this book? Okay, it's just a surface, right? It's just a surface, and it has, this is one of the surface of the book. This is another surface of the book. Okay, this is also one of the surface. This is also one of the surface of the book. This is also one of the surface of the book. So how many surface we are having? One surface, then back, another surface, okay, then top, another surface, then this one, then this one, and this one. Can you tell me how many surface we are having in this book? How many surfaces there? Please unmute yourself, anyone, and
Ma'am,
tell me.
6.
Six.
Ma'am,
Six
6.
surface we are having. Okay, 1, 2, 3, 4, 5, 6. Total 6 surface we are having in this book. And if you will focus on any of the surface, if you will focus on any of the surface, can you just focus on this rectangle, the first one? Can you see only length and breadth is there? Only length and breadth is there. So be it any surface, all are having just length and breadth. And if the question is getting like in your mind that what about the square? Square is also having length and breadth. For the case of square, both length and breadth are same, but square is also having length and breadth. Okay, so when I am telling length and breadth, it doesn't mean that I'm talking about the rectangle only. I'm talking about a surface, okay, which is having two measurement, length and breadth. Okay, be it the surface can be square, the surface can be like this rectangle, anything. The surface can be circular also. Okay, so length and breadth in the shape of circle also you have seen that we take, when we take the area, we take pi r square. This r we take 2 times r into r. Okay, so there also we are doing the multiplication. The way we do the multiplication of length into breadth in rectangle, the way we do the multiplication of side into side in square, similarly we do the multiplication for circle also. Okay, so when I'm saying their surface, it is having two dimension. Surface is having two dimension, length and breadth. Now let's recall everything. Point is having no dimension. Point is having no dimension. A straight line is having only one dimension. When I am saying dimension, no, just replace it with measurement. Dimension means measurement. Okay, so point has no part. That means point has no measurement. Now a straight line. A straight line has one measurement, that is length. Okay, straight line has one measurement, that is the length. Now this surface is having two measurement, that is length and breadth. Okay, and that's what is written over here. So we need to connect everything. We need to combine all the concept whatever we have learned so far. We started with the point. Point has no part. Okay, then we moved on to the straight line, or just say a line. Okay, we said that the straight line is a breathless length. That means it has just one length. Okay, then we moved on towards the surface, and surface has two measurements. So here no measurement. Okay, here one measurement. Here two measurement. Okay, that means length also is there and breadth also is there. So this one, the second one we call 1D, one dimension, 1D. Okay, the second one we call 2D, 2D geometry. Okay, two dimension, two measurement is there. And the first one, no dimension, zero dimension is there. So far, is it clear to everyone?
Yes, ma'am.
Yes.
Okay. Okay. Now the next definition. Apart from this one, we also have discussed that line is completely made with the points. Okay, all the points are evenly sitting on the line and combined together is giving us a straight line. Now the next definition says that the edges of a surface are line. Edges of a surface are line. Just a second. The edges of a surface, we are talking about this surface. The surface can be like this also. Okay, the surface can be anyway. Okay, the edges are just a line. You can see edges are also line. This is also line. Edges are line. This is a straight line. This is a straight line. This is a straight line. Okay, it is completely made with the lines only. Okay, the surface, if this type of surface we are having, then you can take this like a smaller line. You can understand that is smaller lines are there. So any surface that is completely made with the lines, points are packed together, points are collaborated together, points are going to just connect together and make a line. Now line. If I will draw so many line, more lines like this. At the end, if all the line will just get attached together, it will give us a surface. Can you see this surface? Can you see this surface? Can you see? It is also one of the surface. Are you able to see it? So we are getting the seeds. That seeds just packed together is giving us a line. That seeds packed together is giving us the thread. Now that thread packed together is giving us a piece of cloth, piece of garment. Okay, a piece of garment. You can also connect this concept with the real life concept. If you have seen anyone making the woolen cloth, have you seen making the woolen cloth? They just buy the wool from the market and they just keep on stitching, and after a few days you will see that they are having a surface in their hand. Yes or no? They started with a straight line. They started with the line, be it a straight line, curvy line. They started with a line and they are having now surface in their hand. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so that is the one of the example which we have seen. We all have seen. Okay, that's why we say that points are just combined together is giving us a straight line. Straight lines or just a line, be line, when I'm saying it can be straight line, it can be curvy line. Okay, line means it's a straight line, curvy line, and both are acceptable over here. We are not talking about a straight line which we are drawing with the help of ruler. No, line means it can be straight line, it can be curvy line. That line combined together is giving us a surface, and we have seen that surface. Now let me go one step ahead. Surface combined together is giving us a 3D shape. Have you seen 3D shape? That yesterday they were having a piece of cloth in their hand and they were having a surface in their hand, and today I can see they are having a cap. Today they are having a cap. They have just stitched the surface and given it a shape of three-dimensional figure. Okay, this type of three-dimensional figure, they have given it a shape, and that is now 3D figure. How we got this 3D figure? From this, like, surface combined together, surfaces combined together is giving us a 3D shape. Yesterday, when I noticed, they were having a circular part, okay, of the cloth. They were having a rectangular part of the cloth. And today, when I'm noticing, they are having a cap in their hand. And that is one of the best example that surface got combined together and now became a 3D surface, 3D figure. Completely, it's a 3D figure. It has 3 dimension. It has length also, breadth also, and height also. Okay, it has length, breadth, and height also. If I will take a surface, if I will take a surface, we'll roll it down like that. We'll roll it down like that. It is just a cylinder I got. If I will take a circular lid and will paste it over here, a circular lid and will paste it over here, it will be completely a cylindrical shape. Say yes or no.
Yes,
Yes,
yes, ma'am.
yes.
Yes, ma'am.
Okay, let's connect all the concept. Let's connect all the concept. That point we are having in hand, that is giving us line. Okay, point combined together, converted to line. Line combined together, converted to surface. And surface combined together, converted to 3D figure. When we were having point, what is the dimension? 0 dimension, no measurement. When we were talking about a line, what is the dimension? 1 dimension, only length was there. When we were talking about the surface, what is the dimension? 2 dimension is there. Okay, and when we are talking about the 3D figure, a cylinder, a cap, a sphere, whatever, it has 3 dimension. It has length also, it has breadth also, and it has height also. So these are all the definitions which we are having, and these are not all the definitions. These are the only 6 definition which is given in your book, which you have to use while giving, like while fill in the blanks question or any other type of question. You will find this definition will be used over there. However, whatever we use, like most of the definition in geometry is given by the Euclid only. For example, we say that perpendicular line means there is a line. If two lines are arranged in such a way that there is a 90-degree in between these two lines, that's called perpendicular line, given by Euclid. If two lines are arranged in such a way that the distance between both the line are always same, even if you will just increase the line and will just keep on drawing beyond your copy, and the distance between both the line is same, that is the example of parallel line. These all the definitions are given by Euclid's only. So mostly all the definition which we say in geometry is given by Euclid, but here we must stick to these definition. 4, 5, 6 definitions are given over here. Just a moment. Yeah, 7 definition, just 7 definition is mentioned over here in your book, and we will be using it. Like here, you can expect a true false question from this definition. You can expect fill in the blanks question by using that these definitions. Okay, these type of question will be there in your exercise or maybe in the exam or test. So what you have to do now, if you have understood so far everything at home, what you have to do, you have to read each and every definition carefully. Each and every definition, read it carefully at least 10 times. Okay, so that all the definition will just get copy pasted, it will just get registered in your mind, because when the fill in the blanks question will come, then what you will fill, you have understood the definition, that is fine, but when the fill in the blanks question will be there, you must fill it properly. Okay, so that will only come when you will read the definition carefully and will keep on revising it the way you do for any other theoretical subject. Okay, you just go and you keep on revising it so that you will not forget. Here also you have to revise the definitions and the axioms which we are going to talk now, like that only. First, let me know, so far is that clear to everyone?
Yes, ma'am.
Yes, ma'am.
So today that's your homework. Okay, just read the definition carefully and very carefully. Okay, we will be taking a lot of fill in the blanks in our next class. Now let's continue with the axiom. Okay, so now we will be talking about the axioms. Axioms means, yesterday I said, it doesn't require any proof. It is completely based on the observation. Who has given this observation? Our mathematicians. Euclid have, like a lot of different mathematicians has given different axiom, but here we are talking about Euclid geometry. So this axiom which we are going to discuss over here is completely given by Euclid only. Okay, so axiom. After that we will be talking about postulates. Postulates. So both are just observation. Okay, on the basis of observation they have concluded, they have just taken out few conclusion, and that conclusion only we are going to discuss over here. Okay, what is the difference between axiom and postulate? Both are exactly the same thing, that is just completely based on observation. Proof is not needed, but this axiom we can use anywhere in mathematics. We can use this word axiom anywhere in mathematics, and postulate is completely just limited to geometry. So this word postulate we will be using in geometry only. However, axiom we can use anywhere in mathematics. While discussing probability, while discussing any other chapter, I can use this word axiom, but postulate I'll be using for geometry only. Okay, however the meaning of both is exactly same. Some such a statement which is completely based on observation, such a conclusion which is completely based on observation, proof will not be needed. Okay, let's discuss about the axioms. So the first axiom is, when we are going to talk about the axiom, lot of axioms are there, you have to memorize it line by line, word by word, you have to memorize it. Okay, like 1 2 3 4 5 6 7 8 few axioms we will be discussing over here. You have to just memorize a sequence, in a sequence the way I'm going to write it, not necessary. Okay, not necessary, you just have to write, you just have to memorize each and every statement properly, that's it. In a sequence you don't have to memorize. Okay, just each and every statement must be clear to you and must be there in your mind. But postulate you are going to memorize 5 postulate we will be discussing. So every time whenever I will call postulate 1, so everybody from here is going to give the same statement. When I will tell postulate 5, so everybody from here is going to talk about the same statement, but not about axiom. Axiom, we are having a set of axioms, few collection of axiom. You just need to memorize it by like each sentence. Okay, sequence doesn't matter. And yes, memorize means what? First you need to be clear with it, what exactly it is trying to convey, what exactly it is trying to say. Okay, let's take the axiom. So the first one is things which are equal to same thing are equal to one another. Okay, things which are equal to same thing are equal to one another. What exactly that mean? Let's see that. Suppose we are having things, let's say two boxes we are having. Both the boxes are same or not, we don't know. Two just random boxes we are having. Okay, things I have taken, two different things I have taken, which are equal to the same thing. Which are equal to the same thing. That means suppose in this box I am putting this x. In this box also I am putting the same x, which are equal to the same thing. Or you can take two things, x and y, which are equal to the same thing. X is equals to 2 and y is also equals to 2. X is equals to 2 and y is also equals to 2. Then what the statement says that things which are equal to the same thing are equal to one another. Can we say if x and y, two different things, okay, which are equal to the same thing, that means x also 2 and y also 2. So can we say x is equals to y? Can we? Can we? Yes or no?
Yes, ma'am.
Yes.
That's what the statement says. Okay, we will be using the statement as it is while solving the question. While solving the question as it is, the statement we will be writing. Okay, we have solved the problem. From where are we solving the problem? In bracket we will be writing things which are equal to same thing is equals to one another. That concept we are using here. Getting it?
Yes, ma'am.
So that's the meaning of the statement, which is obvious. Okay, which we know that two things are there which is equals to the same thing. Obviously it will be equal to one another. What's new in that? Yes, obviously it is equal. We need to memorize this statement and we have to use this statement while doing the proof of any theorem or maybe while solving the question. Okay, let's continue. Next one, if equal are added to equal, the remainders are equal. If equal are added to equal, the remainder are equal. That means if two things which if two things which are already equal, okay, if two things which are already equal, okay, are added. Here also I am adding something, here also I am adding something. Okay, what I am adding? Equal I am adding something which was already equal. Don't worry about the statement. This is how the statement is written. If the statement is not clear, just after reading the statement you are not getting what exactly the statement says, no worries, that only I am trying to explain here. Okay, that's why we need to discuss what exactly the statement is trying to say. Okay, every time it will not these are mathematical language, we have to decode it. So if something is already equal, if some x and y is already equal and we are adding equal to them, we are adding equal to them, the remainder, that means the final result, remainder means the final result will be again equal. Yes or no?
Yes, ma'am.
So again, this is statement, if equal are added to equal, the remainder will be equal. If already two things are equal, you are having 20 oranges, I am having 20 oranges. Now someone came and has given us two, like 5 orange to me and 5 orange to you. Still we are on the same page. Okay, still we are equal. Yes or no? Previously we were equal. Something got added in your part, in my part. Okay, what is 5 is getting added in my part, and 5, the same 5 we are adding in your part. So still we are equal. Previously also we were equal, now also we are equal. And the same concept we do apply when we solve any equation. Whenever we solve any equation, let's say x is equals to, suppose you are having x plus 2. Suppose we are having x plus 2 is equals to 5. How quickly you find x value as a 3? How quickly? What we do? We say that this and that part is equal. Okay? The term on the left hand side and the term on the right hand side is equal. Why equal? Because there is a equality sign. There is a equality sign. An equality sign has to be valid both the side, even if it looks like equal, or maybe it doesn't looks like equal, it is equal. Okay, just a moment now. Let me share it again. Automatically it just got closed. Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Yeah, instead of plus 2, let me take minus 2. Okay. Okay. Now I am saying that this side and that side is equal. Why? Because there is a equality sign. Even if it looks like equal or not equal, doesn't matter. Equality sign means both sides are equal. Okay. If you will add, let's say 2 over here, and will add 2 over here, still it is equal. If you will add 2 on this side, that's what we do. Previously solving the equation was like this only. Okay, later on we realized that we can also transpose, but before that mathematicians have discovered this one at first, that here minus 2 is there, so we need to add 2 over there. The same 2 we have to add on the other side. So previously something was equal, x minus 2, previously x minus 2 was equals to 5. Okay, left side right side equal. Now when we have added plus 2 and plus 2, still we are maintaining the equality sign. Still we are maintaining the equality sign, and hence we are getting our answer x equals to 7. 2 2 gone and 7. So the whatever Euclid is saying, that is not just very like it's a common thing, it's very normal. That common thing only from the very beginning you are using while solving the equation also. Okay, so if something is already equal and if you are adding the same part on both the sides, still it will be equal. Similarly, we will be having one more statement where it will be about subtraction. If equal are there and if you are subtracting same part, same number, same term from both the sides, still it will be equal. Okay, that will be our next statement. So far, is it clear to everyone?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, word by word you have to memorize it. Why? Because once you will solve the theorem, proof, or what question, you have to write it in a bracket that you used one of the axiom. The number of the axiom you don't have to give. That's number 2, number 3 I am using. No, you have to write a statement by statement that we know that if equal added to the equal, the remaining is equal. Okay.
Yes, ma'am.
Now the next one. As I said, if equal are subtracted from equal, the remainder are equal. No need to explain it, right? Right? No need to explain it, right?
Yes.
Okay, let's move ahead. Things which coincide with one another are equal to one another. Things which coincide with one another are equal to one another. Things which coincide. Coincide means suppose I am having one of the palm. Can you see my palm? Okay. And the other one. Okay. If I'm keeping it on the first one, can you see it is just covering? It is just covering the first one. That's the meaning of coincide. Okay. If it is completely covering, if both are covering each other completely, that means it is equal to each other. If you are having a triangle, and one more triangle, you are going to take the second triangle and place it on the first triangle, and completely both are covering each other, both are coinciding. That means completely covering each other. That means both are exactly same. Yes or no? Same in what? Same in shape and size. Yes or no?
Yes, ma'am.
Okay. Let's read the statement. Things which coincide. Coincide means overlap. When you are going to, like, one is there and you are going to place the other one on that. Okay. And if it is just completely covering each other, that means both are exactly same. Both are exactly equal. Equal means equal in measurement. Equal means equal in measurement. Okay. And that's the meaning of this statement, that things which coincide with one another, which completely cover each other, that are equal to one another. That means that are equal in measurement, equal in shape and size. It is not possible for a triangle to cover a circle completely. Okay. It is not possible. So both the shape has to be same. Same. Triangle can cover triangle. But apart from being triangle, it has to be same shape. Okay, same size. I mean, all the sides has to be same. Then only it will cover. If you are having a square, and you are having another square, will it cover each other completely? No. So apart from being square and square, both has to be same measurement. Here also, here if the side is 8 centimeter, there also side has to be 8 centimeter. The measurement has to be same. Then only it will completely coincide. Okay, coincide with each other. That means completely cover each other. Okay. Is it clear so far?
Yes, ma'am.
Now the next one. The whole is greater than the part. The whole is greater than the part. If I am having a whole pizza and you are having a part of the pizza, obviously I am having greater, like more pizza than you. Yes or no? Yes or no?
Yes, ma'am.
Does it require explanation that the whole is greater than the part? Part means what? Part of the same. Okay, part of the same pizza you are having. Okay, part of, like, if I'm having pizza, you are also having pizza. Okay, the same shape pizza is there, you are having part of just maybe another pizza, I'm having the whole pizza. The whole complete one I'm having. And you are having part of the same pizza. whole means whole 5 is greater than, if you will do the part of this 5, that means if you will divide 5 by any other number, whole is greater than part. Whole is greater than part. Got it?
Yes, ma'am.
Let's continue. Next one, things which are double of same thing are equal to one another. Things which are double of the same thing. Okay, again, x is there, y is there. Two things are there. We don't know whether that is same or not. Two things are there. X is there, y is there. Okay, which is double of the same thing. Okay, let's say here we are having k. X is double of k. X is double of k. And y is also double of k. Are equal to each other. Equal to one another. So things which are double of same thing are equal to one another. Yes, things which are half, even if instead of double, if we will be taking half, which is there in the next part, that things which are half of the same thing are equal to one another. Yes, if x and y, two different things are there. Okay, let's say, yeah, this is the best example. Other example can confuse you. Things which are double of the same thing, x and y, two things we are having. Now there is one more thing, that is k. Now which are double of same thing, x is double